Professor Belfrost's computer science class is back!
Hi, welcome back to my class. And here you'll begin with me explaining, and you'll have tutorial on a review on Boolean algebra. This is still a set of digital system. Okay, this is part of our learning on ALU. Okay, so let's start. Okay, so we will review some problems with the Boolean algebra. This is not very difficult actually. Number one, find out the value of the expression, then create the truth table. So to answer, easy. There are actually several ways. You can just, utilizing the distributive property, and then you notice, I'm sorry, actually, maybe there's something, oh no, it's already correct. Okay, and noticing another property, so you see that, oh, A and its complement added together will result in 1. So 1 added to B complement, but 1 added to everything will result in 1. Okay, that's how you can simplify it. Or you can convert the outer part to create it as shown, and then utilizing the property of A multiplied with A naught, okay, in Boolean operation, okay, A ANDed together with its complement will result in 0, and 0 ANDed together with B will result in 0, and the complement of 0 is 1. This can be done, or you can utilizing the truth table way as shown in the slide, okay, and you check which will give you that result. There is only one answer, which is 1, because all is 1. Okay, 1 is the solution. Number 2, find out the final solution of this expression. So we need to evaluate the solution. Yeah, this can be done several ways too. So yeah, I'll not read it one by one. You need to evaluate this slide by yourself. This is all about how you utilize the Morgan's law. Okay. Number 3, solve for this expression. So this is all about evaluating expression. So actually there are some ways too you can make use of, as shown in the slide. Okay, so actually all very basic properties. Okay, the first way, second way, and the third way is by utilizing truth table method. Easy. Number 4, apply the Morgan's law and solve for this expression. I'll also not read it one by one for you because I have typed it all the solution to you. I want to evaluate it by yourself because it's better when we explain all the the computer things, computer expressions. It's actually not worth it for me to read it one by one because I can mispronounce it. Okay. Then number 5, find the complement of the expression. Very easy. Complement. You just need to take the complement of the whole expression. It means that, yeah, the variable will be the complement of the variable. If it is positive, it will be negative. If negative, it will be positive. Then the operation, if it's AND, it will become OR. If it OR, it becomes AND, as shown in the slide. And you can verify your result by creating the truth table. This is called the perfect induction, as shown in the slide. Number 6, simplify the Boolean expression. You have two Boolean expression that needed to be simplified. It's actually easy too. Okay, but for the first one, we need to expand the bracket one by one. Okay, first we take the first and second one, and then after we have solved for it, we can take the result and solve it with the third one. Okay. And for B, we need to actually pay attention to which factor is common for the terms, at least two terms. Okay, and by Doing that, we can proceed with the next step. Number 7. Given the Boolean expression, then draw the logic diagram. It's easy, right? Just draw the logic diagram. Then you're asked to minimize the expression. You are not told how you should do the minimization or the reduction of the expression. So you can make use of Boolean algebra. You can make use of Karnaugh math. You can make use of McQueen-Klasky way. It's up to you. And then draw the logic diagram for the reduced expression. Here is just the example of the solution. The logic diagram is actually straightforward. But the simplification step here, I'll show you how to do this with just simple Boolean algebra, because actually this time we are not facing uh, very difficult function or expression to be simplified. If you are facing more uh, complicated one, maybe you need to consider using maybe I'll first recommend you to proceed with Karnaugh math if it is possible. Okay, after doing this simplification, we got reduced expression, then we can draw the simplified diagram. So, and then minimize the following Boolean expression using Karnaugh math. This is okay. In this problem, we are asked to utilize the Karnaugh math. So you must do it in that way. Actually, it's very easy, right? First, count how many variables you use. We have A, B, and C, and D. So they are there. So we need 60 cells in total. We arrange the cells as shown, and then we group the ones, get the minimized expression. Yeah, that's done. Number 9. Read out some possible Boolean expression for the Karnaugh math shown below. Yeah, for some Karnaugh math, there are no single answer because you can grow in any ways that you want, and the simplification rate is also maybe the same. So it's up to you. So here are some possible combinations, and maybe you can find more. Please tell me in the comment section. Okay, number 10, prove the following by using truth table. Actually, very easy. You just create the truth table for the right hand side and truth table for the left hand side, and you just need to equalize these both columns to see if all suits. Okay, number 11, by utilizing Karnaugh math, minimize the following expression. You have 5 expression to be simplified, and here you should proceed with. Okay, it's very straightforward. Here all is very clear. You don't have a don't care situation. I put the don't care situation in the learning resources I provide in my website, so don't forget to check it. Okay, number 12, for a given truth table, then find out the logical expression by using Boolean algebra and minimize it using Boolean rules or Karnaugh math techniques. It's also actually quite simple. Okay, number 13, you have 2 points to resolve. First is to express the Boolean expression to the standard SOP, and the second is to express the following Boolean expression to the standard POS. So there are different things. Okay, SOP means sum of products. So we need to have the first thing you need to pay attention with SOP and POS is that all of the variables need to appear in all the terms. So you cannot have like AB plus CD. That's not how you work with um, SOP and POS. Okay, if you have the expressions um, written in the form of something missing, I mean like AB plus CD. Okay, for AB term, then you miss C and D variable. For CD, you miss the A and B variable. That it cannot be. It is not in standard form. So you must proceed with the steps shown in slide. It's quite long. Okay, that's why Actually, this is very important, but I want to read it one by one because I want you to comprehend by yourself. Okay, so here's the solution for A. Actually, it's very easy. This is just say a very simple manipulation, but it needs some time for you to process. And this is how to second. Can you see the difference between the SOP and POS form? I think it's very straightforward, right? Number problem for this, that you have the standard POS expression, okay, with three variables, and you are asked to write an truth table. Actually, this is very easy, okay. POS output all is 0, okay. So the other one that is not stated here means its output is 1. So yeah, that's easy. Number 15, the following SOP expression on a Kano map. First, this expression is actually not in standard form because you see the first term B not C not missing A and D, AB not missing C and D, ABC not missing D, okay? Only the third, fourth, and fifth term, and the fourth, fifth, and sixth term are in the complete variables, okay? So you need to change all the form first as shown in a yellow box on the middle of the slide. Then after this, you can just map each of the resulting by placing a 1 in the appropriate cell on the 4-color Kano map, all meaning there are 16 cells, as shown in the slide. Okay, that's done for the discussion on the review on Boolean algebra and the operation. So here are some little exercise for you. Number 1 to 5, number 6 to 8. Okay, I think that's all. Please take a screenshot. And here are number 9, 10. I have 10 exercises for you. I forget. Yeah, I think that's all for today. There's a little quote for you. So Barbara Kingsolver once said that the changes we dread most may contain our salvation. But yeah, that's worth doing. And yeah, thanks for watching. Subscribe, give a like, comment, and share this video to everyone. I'll be back on every Monday. Please don't forget to visit my website on sciencewithxysd.uneux.com to access more learning resources. I'll see you in the next class. Goodbye.